Section 6.6, homework problem number 6. So in both A and B, we need to make math drawing, so make sure you do that. And use your drawing to help explain why the division problems of 2.14 divided by 0.36 and 215 divided by 36 are equivalent. So we sort of explained it in number 3 using pennies, converting dollars to pennies, or using this fractional form, but this time we are asked to use the drawing to explain. So this is a third explanation. And similarly, you can use the drawing to explain why these two divisions are equivalent. Dividing these two fractions and the whole numbers actually are equivalent. And part C, discuss how A and B are related. Okay, so let's look at my example. I'm going to use these numbers to explain. So again, when you cannot use the pennies, converting dollars to pennies, or a fractional form to explain, you have to have math drawing. So what we do is, this is something we did in chapter 1, how to use bundled objects to demonstrate a decimal. So for example, we use we first demonstrate 1.7. And so what we did is because when we look at these two numbers, 1.7, 0.29, 9 is the smallest place value, which is the hundredths, and this is the tenths, and this is the ones. So when we use bundled objects, we need to start from the smallest. If you start from the largest, you have to divide by 10. And if you have one toothpick or one block, you cannot really divide a block into 10 equal parts. So you want to start with the smallest place value. You can multiply by 10, which you just take 10 of them. So here, each cube represents 1/100th or 0.01. Now notice we have 9 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 blocks represent 0.09. Now here, this long strip apparently has 10 of these if you count, and we know hundreds place 100th times 10, it's going to get our next place value, which is the 1/10. So each of these long block of cubes, that's 0.1, 1/10 or 0.1. Because we have 2 of these, so 2 of these will represent 0.2. Putting them together, that gives us exactly 0.29. So that's 0.2, that's 0.09, so together it's 0.29. So that drawing here demonstrates the second number, 0.29. Now let's look at the bottom drawing. And notice each of this long strip of blocks that represents 0.1. So we have 1, 2, 3, 4, 5, 6, 7 of them. So all of these together, that's 0.7. And now notice we put a 10 of these, so which means we take each of these is 1/10. If we take 10 of these long strips, multiply by 10, it's going to give us the next place value, which is again tenths. If we have 10 tenths, which means you multiply tenths by 10, that's going to give you how many ones. And so this is 10 of them. 10 of the tenths would make a 1. So putting them together, that is exactly 1.7. So this number 1.7 can be demonstrated. So this is 1.7. So let me erase everything here that I don't need. So all we need to know, first of all, you need to know how to come up with the drawing. So that's how I got 1.7, because 1 cube represents 0.01. A long strip, 10 of them, 0.1. A big one is going to be, I'm just going to draw roughly, and that's 1. So this is 0.29. Okay, so now let's look at, so first I started with that. But we also learned this in chapter 1. We can change the value of a block. So when we say each block represents 1/100th or 0.01, that's the value of each drawing. But if I change the value of the block from 0.1 to 1, so what if a block represents 1? Now 10 of these will represent 10. So this long strip, I'm going to just put in the parentheses. If it's changed to 1, times 10, it's going to be 10, times 10 again, it's going to be 100. So the values will also, if I change the value of the one block, the other values will also change. So now let's look at the value represented by each drawing. And because each of them is going to be 1 now, so we have 9 of these. Altogether, it's going to be 9. And each of these long strip, it's a 10, so together it's 20. So the number represented by these blocks is going to be 29, not going to be 0.29 anymore. And same thing here. So this big one is going to be 100. So we have 170, because each of them is going to be 10, 10, 10. So together it's 70. So 170. So the number represented is going to be 170, not going to be 1.7. So again, same drawing, same bundled objects can represent different numbers. And we did a homework problem similar to this, and they ask you this drawing can represent which other two decimals, because all you have to do is to change the value of the block, because nobody says the value of one block has to be 1 or has to be 0.1. It could be any value, but you have to be consistent. If one block represents 0.01, and 10 of them will be 0.1, 100 will be 1. But if one of them is 1, 10 of them will be 10, 100 will be 100. So we do have to be consistent. And so depending on which value we pick, and we can get different numbers. So here, going back to, so we have the drawing. They ask us to make a math drawing, which we have done now. And next, we want to explain why these two divisions are equivalent. So we can start with the one with the whole number because it's easier. 170 divided by 29. It's literally asking 179 contains how many 29s? So same thing here. 1.7 contains how many 0.29s? Graphically, it's asking us how many these many blocks contain how many these blocks. So when you explain here, the question being asked, the collection, how many of the 170 blocks contains how many 29 blocks, which is equivalent to 1.7 contains how many 0.29. So as you can see, does not change. The drawing or the collection does not change, and so they will have the same answer. So whether you're asking 1.7 contains how many to 0.29, it's asking these many blocks contain how many of these blocks. And or when you do 170 divided by 29, same thing. How many of these many blocks contain how many of those many blocks? So that's why they are equivalent, because again they share the same drawings. Both problems are asking these many blocks contain how many of that blocks. Now let's look at part B and part C. So part B, this time we're not looking at the decimal, we're looking at fractions. So first of all, we're going to draw both fractions. So again, I use different fractions here. And notice the fractions have the same denominator. So when I take the one whole, so this is one whole, make sure the second one share the same whole, exact the same length. So I divide in both of them into 9 equal parts, and this is 2/7, so 1/9, sorry, 2/7, 1/9, 2/9, and this is 1/9, 2/9, and 3/9, sorry, 4/9, 5/9, and 6/9, and 7/9. So and you can see right here, I probably shouldn't label in each box, but that means from here to here. And now we're gonna have 7. After we determine the size, after we draw these and highlight the number of parts we have, we can ignore the size of each part. So again, each part is 1/9. But now let's ignore, just count how many parts. So we have 2 parts here. That's for 2/9. For 7/9, we have 7 parts. So when we do division, 7/9 divided by 2/9, that's like asking 7/9 contains how many 2/9? Well, 2/9 goes into 7/9 how many times? But now if we look at the drawing, the graph, don't look at the fractions anymore. Just look at 7/9 means 7 parts. 2/9 means 2 parts. So it's like asking 7 parts contain how many 2 parts? Well, 2 parts can go into 7 parts how many times? So that's why it's exactly like doing 7 divided by 2. And if we just think of the parts, not the size, and it's exactly doing 7 divided by 2. So when we divide either the fractions or whole numbers, and we get the same answer. And part C, discuss how the A and B are related. And when the dividend and divisor in a quotient have the same unit. So what do we mean by same unit? That, for example, for fractions, they have both 7/9, 2/9, they have the same unit, 1/9. So the ninth is the unit. Talking about fractions. For decimals, that would be the tenths, hundredths. So if they have the same units, then we can simply ignore the units without changing the problem of the quotient. And so, for example, so for fractions, we can understand because both of them have the same unit, 1/9. We can just ignore them, do 7 divided by 2. For decimals, it's like this is 1.7. Let me put it right here. Start from 0.29. 0.29, we know this means the tenths and 900th. So we can actually convert this to fractions as we did the practice before. So 0.29 can also be considered as 2900ths. 2900ths. But so if we turn 1.7 to the hundredth, of course it's 17 tenths, but 17 tenths can also be turned into 170 hundredths. So now they have the same unit. Both of them have a hundredths, right? So if I use words, that's 29 hundredths and 170 hundredths. And we do need to turn it into the same unit. We cannot use this means 17 tenths, and that's why we cannot compare them because tenths and hundredths, they're not the same. So that's why we always have to make sure we move the same number of times. So both of them have the same units. So that means we just need to, we can ignore the units, 100, the hundredths, we can just divide the 170 by 29. So that's why they have the same answer.